So um, this part I will create a quick T part from React, and what I want to do is I want to implement Redux first of on its own, because I think that's quite an integral part of the infrastructure, not actually infrastructure, but like the ecosystem of React. Because if you think about it, like a lot of apps, like really big apps using Redux or Redux-like architecture. With the hooks, you got use reducer, which is basically the same thing. Reason React ships by default with a reducer like dispatch system. So I think it's worth digging into how it works. I think it's a fairly easy library, so we can get I mean easy in terms of like once we get into the implementation, except for the last bit, which will be a bit tricky. So I need to dig into some functional programming, but I hope it's gonna be fun. So first of all, I wanna create a new branch, like Redux, and start it. And in the source we have React and React DOM, and it's time to put Redux there. So I don't know how to structure this. Probably it will just have an index which will export everything that is needed. And again, I'm trying to build it like from the API perspective. So if we come into the React Redux stuff, basic examples, let's try these things out. Okay, so first what I want to do is I want to modify the client here. So first I don't want to have any React stuff, and in order to have that I need to comment this out. So instead I want to have import, so we need first a create store function. So I want to import create store from Redux. But in order to do that I need export default as create store from probably create store. So I need new folder creates, that's not what I want, that's again not what I wanted, create store. And here I will have an index.js where I will have export default, just an empty function that will do nothing at the moment. Okay, so if I come here and save everything, so I have create store here, I just wanna have create store, so I wanna call create store simply, without it throwing an error. Can I do that? Yeah, I think I can. And what if I go to create store and do something like console log hey dude, refresh it, and hey dude. Okay, so we have create store. Okay, so if you're familiar with I'm not gonna explain how Redux works. So if you have never used it, Redux, never used it extensively, you don't know what it's for, that's not the video that you are looking for. I assume that you're fairly familiar what Redux is. So let's just dig into the API. So create store expects two arguments, I think. It expects by default, you can get away with a reducer, so definitely you need a reducer, but we're gonna use an initial state as well. So the way we wanna use it is we want to have a reducer. So reducer looks like something, a state and an action, and we're just simply going to return the state for now. And we want to have an initial state. So const initial state will be an object with to-dos, which will be just an empty array for now. So I want to have a reducer and an initial state. Okay, so the way it works is it returns you a store, right? Obviously, as the name implies, create source should return you a store. So here's the store, and you can subscribe to the store. So then you can store, subscribe, and it accepts the function. It's strange. Okay, so it accepts the function console log store.getState. But I think that the argument should be store as well, but let's just keep it that way. And you can do store.dispatch, okay. And what we want to do is we want to like type. Let's actually const add to do, which will be add to do. And the payload will be just payload. What was so that's gonna be a payload, a to do. Payload gonna be this boy. Okay, so that's the API. So that's what we need to first implement to make it work, because it will throw an error at the moment, I think. Yeah, so cannot read properly subscribe of undefined. Well, it makes sense, right? So it accepts a reducer, and it accepts an action. No, not an action, initial state. Initial state. And it returns a store. So it returns a store that has the following methods. It has a subscribe. So it exposes a subscribe, which will be a function of some sort, right? It exposes a dispatch method, which again is a function of some sort, and it exposes a get state, which again is a function of some sort. So I think now we shouldn't get an error, but it obviously doesn't do anything. But at least now we have a very basic interface. Okay, so what we should do is dispatch get state. Okay, so let's think about it. What is a store? What is a get state? So so first let's create a, so we're gonna utilize that you can have variables that are scoped to this function, right? So we can create something current state, and we can just set it to initial state at the moment. And with get state we can create an abstraction over the current state. So get state can simply return the current state. So now it's not going to do anything with the subscription, but I can simply get like store dot get state. So I can simply get store dot get state. So const state, I can console log this out. Console log state out. Yeah, so to-dos is an array of nothing because we assign it to the initial state. Okay. Alright. So the next thing is dispatch. So dispatch is quite the heart of the whole thing. So what dispatch does, it gives your store some blueprint of what needs to be done. Then it invokes the right reducer and calculates the new state and gives back an immutable new result and reassigns it to the current state. So what it does is we can simply create again an abstraction. So let calculate state, which can be a function, and what it can do, it can receive an action and it can actually invoke your reducer with an action with the current state. So now you have the current state and the action, which will actually produce a new state. So you can do current state equals reducer action state, and you can actually call this function inside your dispatch method. So calculate state with action, and obviously you need to pass the action to the dispatch function. So it's pretty easy so far. The basic infrastructure is pretty easy. Let's see if it's working now. So we need to have our reducer in place. So the classic switch action.type, we need to have action set to default, while we just simply return state, and in case it's add to do, we wanna return state dot to do dot concat to do or to-dos dot concat action dot payload, and that's gonna create an immutable stuff if I'm not mistaken. Yeah, okay, so now we can dispatch things, and this reducer will get invoked just in the current state, and the current state gets updated. So since it's all synchronous, very simple code, we dispatch it here. So when we get to the state, we shouldn't receive an empty array as we did here, but an array with value with one to do in it. And as you can see, we have one to do in it. So that's pretty damn good. Okay, so let's do another thing. Let's actually create let's actually not assign the initial state there, but do something like when the function runs, let's dispatch one of our internal actions. So let's call calculate state with type in it. So instead of assign, this will later when we have combined reducer, this might get handy. So we're not using the initial state right now, but what we can do is we can use sort of like higher order functions or function composition. That's pretty neat stuff. We need to talk about that later on. You must have used it quite extensively with higher order components, higher order reducers, just simple function, like putting functions together. But the general concept will come up a lot. But what I just simply want to do is, but we don't even need that. We can get away with that for now. It's I think it's gonna be easier. It's if action type action type equals init, and then simply assign the current state to initial state. Okay, so now everything is set up, and what we need is this subscribe stuff, right? Okay, so let's assume that I don't wanna imperatively get the state here, but whenever the state changes, I wanna get notified. So I should receive two console logs, one for the init and one for the add to do. In order to do so, we need to set up a very basic observer pattern or something like that. So let's do something. Let's subscribers equals empty array. And what we're gonna do is basically subscribe. So subscribe takes a function, right? So what we wanna do is whenever it happens, we wanna push it onto our subscribers, that function. It's really easy stuff. And when we calculated the state and this happened, what we wanna do is we wanna go over our subscribers for each. We have our subscribers, subs, and what we wanna do is we wanna I don't know how Redux does it, but I wanna have the current state as an argument. So you might don't want to do that, maybe it's not a good practice, but I just want to put the current state here. So every time we have a state change, we will get notified, I presume. Calculate state init. Star. For the init we don't get notified. So yeah, because we don't really have that. So we are subscribing to that thing somewhat later. So so the init happens here, and we're subscribing after that happening. So yeah, we're just getting one. So but anyway, you get the point. We're not console logging anything out yet. You get notified that a dispatch stuff happens. So if I create another dispatch with this one as a payload, I cannot reproduce the concat of undefined. Okay, so concat, where is concat? The state to do is concat. Okay, that's interesting. Okay, yeah, sorry. Okay, now, sorry, my bad, I wasn't paying attention to the structure of the state. So now you see that we have two dispatches and we got notified what was happening in our state. So now we have two to-dos in our store. So we covered subscribe, we covered dispatch. let's check what, let's go with their API. So you have create store. It needs a reducing function that returns the next state tree given the current state. Pretty good. Preloaded state, we have that. Enhancer, yeah, that's gonna be the trickier part. Okay, combine reducers. So let's have combine reducers covered here. So combine reducers, actually, let's try it. So let's create another file, shall we? So combine reducers, and it will be an index.js. So it's gonna be export default something, and in the index.js I'm just gonna oops, sorry, create store and combine reducers. We can close this. So combine reducers, it takes a bunch of reducers in a form of an object with a field and the function pair. So ideally what I want to do, ideally what I want to have is something like this. So I want to have the create store, combine reducers, and instead of having a reducer here, I want to have a to-do reducer and like a counter reducer maybe. So I want to have a const counter reducer, which will have the same stuff. So state action, maybe for now it's just gonna return the state, just to keep things simple. And I want to modify my initial state to match this pattern, so I have a counter which will be set to 0. And now I can get rid of this. I think I should be able to get rid of this, but we'll see, right? So ideally what I wanna have is const reducer equals combine reducers and to-dos, to-do reducer, and counter reducer. And that's the API signature I want to have. So let's work on that one. So it receives a reducers here. So what I want to do is basically to not break the API of our create store. So as you can see, we have the reducer is expected to be a function that needs to be called with state and action. So to match that, the reducers, the combine reducers, when you call, it must return a function with a state and action. So that's pretty much the signature that we must have, and it must return some piece of state. So that's the signature that we must abide by. Okay, so what needs to be done is we need to go through the fields. Object.keys reducers, that it will return an array of strings, so we can for each over or map over. Let's see what we can do. So it the reducer name, and what we can do is what we can do is let me think about that. So we need to call every reducer that we have here. So let the reducer function will be equal reducers at reducer name. Okay, that is the reducer function. Okay, so that is a reducer function. Actually, I think I can map over. So if I return the reducer function, so I can do something like rn fns, so reducer functions, that stands for that. So what I can do is if I get back the state and get back the action, I can do rn fns dot for each and that's the function I received. So now I can, well, actually I will need the name, sorry. So let's have it here, because it actually needs to be a for each, and I don't want to return it. So that's the function. Let fn equal. So that is the function, the reducer function itself. So we can actually start having that next state, maybe next state, which will be just an object. So what I can do is I can start calculating the pieces of state by just simply saying that next state at reducer name will be equal to the reducer function called with the appropriate state of the reducer name and with the action. So that is next state, and then I can return next state. I think something like that. I don't know how much sense does it make. So what it does is first of all, it's just partial application, right? We're not using, yeah, so it's a partial application. You pass the reducers in, then we will have the state action, which will be coming from create store. And since you split up the data, so whatever you have in the initial state and whatever you have in the combined reducers, their name fields must match. So what we're doing with that, we have a new object as the next state, and the reducer name, as we said, must match. So from the old state, we are calling the appropriate reducer for the appropriate old state and calculating the appropriate new state, and we are passing the action. So let's actually try this thing out. Cannot read properly concat undefined. Alright, so state to do's, return state. Okay. Counter reducer. To do's. Let's just console log store.getState. Store.getState is there. Okay, that's good. Add to do. Okay, so the state, yeah, because we are just simply matching the name now, right? So we don't need to explicitly tell to-dos, because combined reducers namespaces and initial state namespaces are matching. So as you can see, if we get rid of this, you can see that our state is counter 0, to-dos. First is just one array, then got dispatched the second item. We now got 2 arrays. So everything is working as expected. So combined reducers is doing its job. So we don't even need these. Presume we don't even need these. Let next state should reduce it for each. Stefan. Yeah, I think that's good. Index. So just to make sure everything is working fine, let's create. Let's make it somewhat more complicated. So the classic increment, right? The classic inc state will be, let's return state plus 1. So we have inc, soon inc, and I want to dispatch an increment between the two. So if I think payload doesn't even matter, right? So I'm not gonna reset the payload, but I just to be the clearest possible, I get rid of the payload, so we don't have to bother with that. So now if I get this, you can see first the to-dos get appended, then to-dos and counter gets incremented, and then the second to-do. So I think that's pretty much the basic functionality. Obviously Redux does a lot more, like sophisticated checking, that you not dispatching any action while the store is being created and things like that. But the core idea behind Redux is this. So I think it's pretty easy to grasp. Maybe combined reducer is a bit hard, but it's just simple, like curried function and partial application. So you can pass some arguments here, and then you partially apply the function, and you have access to the previous arguments later. It's quite a common pattern in the functional realm. Yeah, so that's it for now, and in the next video we will get our hands dirty with so we have this bind action creators, and we have apply middleware, which is with this compose stuff. So actually we have bind action creators, which is again an easy one, but I wanna get into the hard thing, the apply middleware, because that's what we are using quite a lot, synchronous, asynchronous middlewares. So yeah, in the next video I'll get into that. So see you until then, guys, and have a good day. Bye bye.